we've talked about aircraft and how much energy it takes them to travel around the world. But how about doing it by rocket? This is an idea that keeps coming back for long distance flights. Rather than fly a plane from Australia to England, which will take you 24 hours and have to go through an awful lot of atmosphere on the way, pushing it out the way, pushing it down to keep in the air, how about you just go a bit higher? Rather than 10 kilometers, go to 100 kilometers. And then you're in space. There's vacuum. You don't need to overcome any drag. And if you go fast enough, so you're at an orbital speed, you don't even need any energy to stay up. Your centrifugal force will keep you up naturally all by itself. And then you can come down at the other side, aerobraking somehow to slow yourself down. And it will only take like 40 minutes to go from England to Australia rather than 20 hours or more. So it's a very nice idea. And we now know how enough to calculate this. If you go back to the space section of the course. Okay, so the problem is you're not going to need to overcome drag because you're going to be in space most of the way. You don't need to keep yourself in the air because the orbital speed will do that for you naturally. But you will need an awful lot of kinetic energy to get to that orbital speed. Remember, orbital speeds are enormous. Remember this delta V? The delta V needed to get into a low Earth orbit is about 8 kilometers per second. Okay, so let's assume we use a rocket like the Falcon 9, the current cheapest rocket. It's squirting its rocket fuel out at VE of about 3.5 kilometers per second. You might get that up to 4.5 if you use a hydrogen or oxygen, but 3.5 is about the state of the art at the moment. So we've got the rocket equation, which tells us we get a mass ratio of e to the delta V over VE, e to the 8 over 3.5, which is about a factor of 10. So that means for every ton of payload you put into space, you're going to need at least 10 tons of fuel. We normally talk more like 20, but 10 is a sort of bare minimum for an extremely low Earth orbit, which is all you need if you're just going to nip around half the Earth and come back down again. So what's our actual capsule going to look like? We have to be able to keep our passengers alive at this high altitude for the 30 minutes or so they're up in space. And more seriously, it's got to be able to steer and navigate into the atmosphere and not burn up on re-entry. Well, we know something that can do this, which will be a space capsule that exists. So let's pick the Dragon 2 capsule as a good modern one. This is the one SpaceX uses to send astronauts up to the International Space Station. It has a mass of 8 tons and carries 4 people. 8 tons seems a lot for 4 people. I mean, you can fit 4 people in a car that only weighs 1.5 tons, but it does have to be able to survive re-entry and provide life support. So that doesn't seem unreasonable to me. So we need at least 8 times 10 tons of rocket fuel, because remember the mass ratio is 10, so for every ton of payload you need 10 tons of fuel. So you need 80 tons of rocket fuel, about 43 megajoules per kilogram. And 80 tons of fuel is about the same mass of fuel that an airliner takes to fly all the way to England from Australia. So it turns out the energy is about the same for an airliner to go halfway around the world and for a rocket. So that sounds great. Rocket can get you there in 40 minutes. Airliner takes 20 hours minimum. Why don't we all fly by rocket? Well, the trouble is that the rocket only carries 4 people, whereas an airline can carry hundreds. So, not energy efficient. If you need to take a small number of extremely rich people somewhere very fast, this might well work, and that could be enough to make there an economic market for it. But in terms of transporting large numbers of people for their European holiday, it's not energy efficient. And that's assuming the best possible efficiency for a rocket engine. So it's kind of bizarre. If you want to go really large distances, rockets are extremely efficient because, sure, it takes a lot of energy to get you into space, but once you're in space, you can fly around forever with no more energy needed. So if you were going hundreds of thousands of kilometers, this would definitely be the most cheap way to do it. The trouble is the Earth just isn't large enough to make it worthwhile. There's no distance far enough at which rockets are the cheap way to do things. But it is very fast. It might be used by very rich people in a big hurry or by the military, so I can see it actually being a market in the future, assuming SpaceX can keep bringing the price down of their rockets and make them fully reusable.